Jupiter's colorful clouds present an ever-changing kaleidoscope of shapes and colors. This is a planet where there is always stormy weather. Cyclones, anticyclones, wind shear, and the largest storm in the solar system, the Great Red Spot. Jupiter has no solid surface and is perpetually covered with largely ammonia ice crystal clouds that are only about 48 kilometers, 30 miles, thick in an atmosphere that's tens of thousands of km deep and give the planet its banded appearance. The bands are produced by air flowing in different directions at various latitudes with speeds approaching 563 km per hour, 350 miles per hour. Lighter-hued areas where the atmosphere rises are called zones. Darker regions where air falls are called belts. When these opposing flows interact, storms and turbulence appear. Hubble monitors Jupiter and the other outer solar system planets every year under the Outer Planet Atmosphere's Legacy (OPAL) program. In the left Hubble image, the classic Great Red Spot stands out prominently in Jupiter's atmosphere, the Hubble astronomers said in a statement. To its lower right, at a more southerly latitude, is a feature sometimes dubbed Red Spot Jr. This anticyclone was the result of storms merging in 1998 and 2000, and it first appeared red in 2006 before returning to a pale beige in subsequent years. This year it is somewhat redder again. The source of the red coloration is unknown but may involve a range of chemical compounds, sulfur, phosphorus or organic material. Staying in their lanes, but moving in opposite directions, Red Spot Jr. passes the Great Red Spot about every 2 years. Another small red anticyclone appears in the far north. In the right image, storm activity also appears in the opposite hemisphere, they said. A pair of storms, a deep red cyclone and a reddish anticyclone, appear next to each other at right of center. They look so red that at first glance, it looks like Jupiter skinned a knee. These storms are rotating in opposite directions, indicating an alternating pattern of high and low pressure systems. For the cyclone, there's an upwelling on the edges with clouds descending in the middle, causing a clearing in the atmospheric haze. According to the researchers, these storms are expected to bounce past each other because their opposing clockwise and counterclockwise rotation makes them repel each other. The many large storms and small white clouds are a hallmark of a lot of activity going on in Jupiter's atmosphere right now, said OPAL project lead Dr. Amy Simon, an astronomer at NASA's Goddard Space Flight Center. Toward the left edge of the image is the innermost Galilean moon, Io, the most volcanically active body in the solar system, despite its small size. Hubble resolves volcanic outflow deposits on the surface. Hubble's sensitivity to blue and violet wavelengths clearly reveals interesting surface features.